watch this later on, if you can.
Yes, that's a good idea. So we will record. So your question will remain forever. So consider carefully. Your question has to be very level question rather than too much funny question. So, Sharup, you wanna have just a brief introduction? What you have received questions so far from other students? I remember some of students tried to contact Malaba wastewater treatment plant to get some information. However, the Malaba wastewater treatment plant is different from our assignment scenario because Malaba wastewater treatment plant is located in the coastal line near the beach, which means they have a very simple primary treatment process. However, our assignment is about secondary treatment, biological treatment process, which is anaerobic bioreactor, aerobic bioreactor, comparing with the conventional treatment plant and membrane bioreactor. In fact, our scenario is not exactly real process of the Malaba wastewater treatment plant. So you just follow the scenario rather than real plant of the Malaba wastewater treatment plant. So that was some question from students. Any other questions, Sharad, you want to share?
I think that was the only question they asked me. Yeah, so mostly it's a lot like what Sean said. The students are asking that they cannot find much information about the Malaba wastewater treatment plant. Yeah, I think it's true because there's no comprehensive report as such related to Malaba wastewater treatment plant. But yeah, so this is like Sean said, it's just a scenario, and if you look at different reports, you'll find bits and pieces in many reports. So it's hard to find just simple in one report everything about Malaba wastewater treatment plant. So if you can, of course, find in just one report, then you refer only one report, and then there's nothing much that you can report to other refer other reports or other publications. So I think that design is also in such a way that you get the exercise of looking at exploring as much information as possible, because if you get information everything from one source, then it becomes much easier, and then your learning opportunity will also be very less. So when you have this kind of quite an open-ended kind of assignments, then the students will have to explore. So in the process of exploring, sometimes you come across additional knowledge. So that's also one of the design that we consider, so that students have access to like by chance or something like that, that you get in the process many different new things that you learn. So you won't get, as I said, won't get the comprehensive report in a single report about the Malaba wastewater treatment plant. But if you look at many reports, you find a little bit here and there mention about the wastewater treatment plant. And so that's how we are expected to do. And basically, we are not really into the Malaba wastewater treatment plant, because this is just a scenario, and the scenario was that you employed, you will be engaged as a consultant, and then it's basically to upgrade the Malaba wastewater treatment plant. So the existing Malaba treatment plant is, in a scenario, is that it has a biological secondary treatment, but actually in reality they don't have the secondary treatment plant, because they have the primary treatment plant, and they have a very comprehensive treatment processes for sludge management, because from the primary treatment they have a lot of sludge, and this sludge they trying to manage it perfectly, and then try to produce biosolids and those sort of things. And because the outfall is, the ocean is very near, so they, after the primary treatment, and they send it to the sea. So the outfall is like, I think, a few kilometers from the shore. So this is what it is. And basically your task is like, what we want you to be learning is that how the secondary wastewater treatment plant is designed, and how MBR is designed. And so you're trying to compare the conventional treatment plant design and the MBR design. So in that way, you are trying to basically understand how much space you can save, how much energy you can save, or how much more energy it could consume if you install MBR. So basically, these two comparisons, when you do that calculation, then you will get into the details of how the treatment plant is designed. So it's I mean, basically the process design is not exactly the whole plant design. So whole plant design involves many, as I said in the class, design involves many aspects of the engineering. It's not only just one engineering, like environmental engineering. So environmental engineering is just one part, it's process design. So to support that, you have civil engineering design, like structural design, we have electrical design, we have mechanical design. So many things are there. So in that way involved. But here you are only focused on the process design, environmental part. So, and in that process, you are working on how much space is required for the bioreactors, how much space is required for MBR, and basically comparing these two and see, okay, this unit process is, if you come up with the MBR instead of conventional electrical discharge process, this much savings in terms of space, because in large cities, as you know, space is a very is a constraint. Unlike in the villages or other remote areas, the space may not be a problem, but in the cities, the space is a big problem. So land cost is quite high. So they want to have as compact as possible because the land is scarce. So that's what you are expected to be doing that comparison, not really finding nitty-gritty about the treatment plant. Of course, if you can find, that's good, well and good, because that will further enhance your understanding. But yeah, you can, when you talk about the advantages and disadvantages of each unit processes, you can find it from any literature sources. It's not just limited to that treatment plant. So this is what this is basically what students were expected, and the questions I got is related to this one only, not, yeah.
Dom, you have questions?
Yeah, if you have other questions, yeah, we're happy to answer.
Dom, yeah.
So much, Sherb and Sean. So I know what you're saying, it's not about the history of the plant. Well, I know that was part of the requirements of a good report. Do we just give a brief history, most things correct, and all spot on? Similarly, with the flow rate into the plant, obviously Sydney Water's got 488 mLD. The report has an average flow of 20 mLD. Should we go with 488, or should we go with 20, or should we go with 488 split off into 25 different CAS processes?
So you are supposed to just follow the scenario that was given, not based on the information from the Malabo wastewater treatment plant.
No worries. So just pretend it's 20.
Yeah, that's correct.
Perfect. Just while I've got the microphone, if I may continue with a couple of questions. More so in the assignment, it's got peak dry weather flow to average dry weather flow ratio is 3:1. The average dry weather flow, it's given as 20 mLD, whereas the peak flow, it's given as 1,000 cubic meters an hour, which equates to 24 mLD. So that peak dry weather flow, should that be 60 or 24 mLD?
Okay. Just hold on. So, can you repeat that question? Yeah, I see that average dry weather flow is 20 mld, right?
Yep. And gives the peak dry weather flow of 1,000 cubic meters per hour
Yeah, yeah.
for 24 mLD.
So that comes to 24 mld, right?
Yeah, that's you know,
So-
1 multiplied by 24 gives you 24 mLD, and one cubic,
So,
sorry,
yes.
1 cubic meter band.
So I'm not sure why this is given. Yeah, actually the peak factor that you have to use is 3.
Okay, so the peak flow is 60.
Yeah, 3. Yeah, yeah,
Perfect.
that's correct.
Yep. Okay, awesome. So I just wanted to clarify that.
Yeah.
Okay, and again, just while I've got the microphone still, thanks for your patience. Are we required to put in a recycle line to mix the nitrified liquor with the liquor about to be denitrified? Are we required to do that? Or
Yeah,
not?
you can. Yes, you can show that it doesn't matter. So, let's say for the calculation, you can do do whatever that procedure that I have laid out in so. But in the diagram, yeah, you can show this is fine, and then you can explain in your description as to why this is why this is being recycled and what are the advantages, those sort of things. What's the function?
Okay, so we do need that recycle line back.
Yeah, that's fine. Yeah.
That obviously just means double the membrane area. That's all.
Mm-hmm.
So, okay, that's all my questions done. Thanks very much. Cheers.
Any other question from other student, Maria?
Yes, from Maria. Yes.
Yes.
Regarding how to calculate the flux management in the end for the MBR, we do have 2 numbers. There's one that in this scenario it says that power flux management will require 3 kilowatts per hour per cubic meter, or on average dry weather flow.
Mm-hmm.
So that leads to some result. But if we use what it said in the step-by-step part of the task description, there's something about flow rate to maintain the permeate flow. And that's quite different, because if you compare power flux management would be 3 kilowatts, and with flow rate we have 0.35 kilowatts. So what do we use? Should we use just the one that is in the scenario, or in the description of task?
There are several ways that you can do the calculation for the flux management, and some of them are more complicated ones. And I think, I'm not sure whether it was mentioned here, so this is a little bit confusing here. So that's why we have given additional information as to how much energy is usually consumed to produce 1 meter cube of the permeate. And I think I mentioned that it was 0.5.
We have
0.3 meter cube per.
it would be, what you've given us, it's 0.3 kilowatts per hour per
Yes, that's correct.
cubic meter.
Yeah, so that's correct. So for example, if you have 0.3, so that what is showing is that if you are treating 1 meter cube of water, the flux management energy is 0.3 kilowatt hour per meter cube. So which means if you are treating 1,000 meter cube, it will be 0.3 into 1,000, right? So 300. So based on that, you already have how much wastewater you are going to treat in 1 day. So from there you can find what is the power requirement for this flux management. Yeah.
Yes.
Yeah, that's the easiest one that you can do it. But
and that's based on permeate flow.
Yeah, based on
on
permit. Oh,
80.
yeah.
Okay.
Yes,
And
yes.
the other number that you provided us is
Mm.
3 kilowatts per hour per cubic meter of air would be?
Yeah,
Because the
so
other
that,
one,
yeah, so can you please discard that one? I think we, in the earlier one, actually we removed that. So because there was some confusion with that, because that 3 kilowatt hour per meter cube air is not the correct one. So it should have been 0.3 meter cube per kilowatt hour per meter cube. So you just use 0.3 cubic kilowatt hour per meter cube or per minute. So don't follow that.
use with air,
Yeah,
discard air.
yeah, got
Okay.
it, yeah.
So this is maybe a dumb question, but all of our bases are going to be around 1 day because some units have kilowatts per day or have a BOD per day. And with our power, we only have kilowatts per hour, not on day. So basically we have to use the conversion of
Yeah.
day. Okay.
Yeah. So kilowatt hour is just what's it like energy.
Rate.
Energy is consumed, right? So kilowatt will be like as instant power that you require. So which means in 1 hour, if it's 1 kilowatt, then if you multiply by one operation for 1 hour, it is 1 kilowatt hour, right?
Yes.
If it is 24 hours, then 1 kilowatt into 24 will be 24 kilowatt hour, right?
That was particular for the power on the final power for the bioreactor because because the load is per day.
Yeah.
And it's just the other numbers are right.
Yeah.
Okay.
So please remember that power is different from the energy. The power is how much power you require, like the capacity of the thing. Energy is how much is consumed, okay? So when you multiply your power with the time, this becomes energy, okay?
Okay.
Yeah.
It was just for the
Okay.
load, BOD load, sorry.
Okay, that's fine. Any other question?
Yes, the second one is that, are we supposed to be comparing a separate module? For example, what I've seen in the classes, in the slides, are that you are comparing the clarifier to the module of membranes, the cassettes. So that is what we're going to use. We're not going to assume that we have a submerged membrane.
Yeah, we're going to have the submerged membrane. So usually it's a submerged membrane. If you want to do,
but not in the bioreactor. Just like a separate. When you see the configurations, you have this one is you have the cassettes submerged within the bioreactor, and the other one you have the bioreactor, and you have some
separate one. Yeah, so we call it external skid. Yeah, so I think you are required to design submerged because here we're trying to compare the real space savings. So when you put it in the reactor, okay. If you put it in the reactor, then you have more savings. But if you put external, then there are additional implications because you need to have a separate pumping that will pump your the MLSS and send it to your membrane and then return it your sludge. So, and it not only requires additional pumping, but you require additional space to keep the membrane. But if you put directly into the bioreactor, then yeah, so you have much savings in the space. So because your task is mostly to compare the space requirements, and yeah, we would like you if you can do it as submerged one.
Submerged within the main bioreactor.
Yeah.
So assuming that is placed in the aeration zone.
Yeah. And so of course you can have a within the aeration, but you can have a separate MBR zone in within that put it. So, but yeah, you can calculate the same.
So it will be the regular volume of the bioreactor from the normal, and then we add that little volume of the cassettes. Okay.
Yes.
Okay, so Dom, also you have another questions?
Thank you. I appreciate the aim is to conserve space, but my understanding is that you achieve better results regarding fouling or less fouling when there's an external MBR rather than a submerged one. Is it still, but you still want us to design submerged? Absolutely.
Yeah, in most cases, yeah, in majority of the system plants around the world, they have submerged MBR because with the proper operating procedure, they can still relatively maintain the flux, the fouling rate. So even if you are doing external skate, you still have fouling. But it's maybe the fouling rate is a little bit higher in the case of submerged one than the external one. But the difference, I think it's relatively small. So compared to the space, the savings from the space. So that's why they usually provide the submerged one.
Okay. Should we try and?
Yeah, you can do that additional calculation of one also. That's fine. Yeah, you can even mention, even if you don't do the calculation, even you can mention it in the report.
Okay.
Like, option. So this because this is a very open-ended assignments. We gave you that structure is just as a guide that you need to follow. You don't have to be exactly same as what we have given in the structure. You can deviate from there. It's if you find a report that's much more better than the structure that we provided, it doesn't matter. So it's up to you to work on. We provided this structure just to make it easy for the students. Sometimes students don't know where to start. Yeah.
Okay, awesome. Thanks very much. Cheers, Sheriff.
Yeah.
Okay, Mansingh.
Yeah, Professor. Thank you so much. So, in our assignment, alternative wastewater treatment system, there is a one point, evaluate and propose an alternative treatment process design incorporating MBR as a new technology to replace some processes of the existing wastewater treatment plant. So I'm a little bit confused about that. Like, do we have to use, because when I was reading articles, then there was lots of MBR was using in a different way with the many systems. So could you explain a little bit about this? What exactly we have to do with this point?
Are you talking about the water augmentation?
No, I'm talking about the number 4, this one, alternate wastewater treatment plant using membrane bioreactor. And the first point, evaluate and propose an alternative treatment process design incorporating MBR as a new technology.
Yeah. So this what you have to. So the current the scenario given is that it has a secondary treatment biological treatment plant consisting of the aeration and anoxic tank, right?
Yeah.
So you will have to do that calculation yourself. Yeah? And then this is the existing scenario given. Now you asked to do the alternate design, so incorporating the MBR, right? So now you'll have to do, okay, you already did the calculation for I would say the conventional activity/process. So this is the one which you are already existing is the conventional activity/process. Now if you are asked to upgrade this one to MBR, right?
Mm-hmm.
Yeah, so now you do additional calculation for MBR if you're putting. So this is what alternative is. Yeah. So once you do that MBR design, so MBR design is basically you're already given how much MBR, permeate production that you need. and also it's given what is the peak flux. All those things are given. So based on that calculation, you will have to calculate how much membrane cassettes are required, modules are required, and then based on that, so this is what you have to do additional calculation, right? And so,
Yeah, you mean like first of all we have to do the calculations for conventional procedure?
yes.
And
Otherwise, how are you going to compare the space requirement? Because we haven't given the space requirements here, so you have to compare how much space is required for a conventional activity/process, and how much space is required if you upgrade this one to MBR. So then you compare these space requirements, because if you upgrade it to conventional activities, let's say the MBR, then you don't require the settling tank, secondary settling tank, right?
yeah,
So you save in terms of secondary settling tank. Sometimes even the people even avoid the primary settling tank. But anyway, you just focus on the secondary treatment plant. And sometimes even, in the conventional activity/process, they have tertiary treatment in terms of the sand filtration. You have aerobic bioreactor, then you have the anoxic zone is there, and then you have the secondary settling tank, and then you have the sand filtration also, depending on the requirement for the effluent discharge. So, but if you put the MBR actually, then you will be saving the secondary settling tank and the sand filtration. So it can work for two processes with just one. So in that way, you can have a lot of savings. But of course, here we didn't say that there's a sand filtration, so you don't have to worry about. And basically, you'll be comparing how much savings you have by putting MBR to the conventional activity/process.
okay. And
Ju-
so
just-
and I think I'm hard to draw a diagram. So could you recommend any suitable software for drawing our diagram?
You can just draw. I usually draw using the PowerPoint, and also you can use Word, whatever. If you're using I would say AutoCAD, you can do it. Some people use Visual something, but yeah, I draw using PowerPoint. That's enough. You don't need the complicated software. It's just show the diagram. Of course, if you do fancy diagram, it looks good. That's fine. But even if it's just the the process diagram, which unit follows which, that should be enough to understand.
Okay, fine. Thank you.
Yes, Tom, just a second. So we have a question from Yutong. So he left the message. So he just want to know whether all the equipment in the process flow chart require us to draw a specific shape or just box and the name instead. Very much similar to Mansing's question.
Yeah,
it doesn't have to be a very beautiful schematic diagram. Yeah, as long as you understand process, that's enough, right?
Yeah. The box diagram should be more than enough. You don't have to waste time making beautiful pic photos and spending a lot of time. It doesn't, because it will not give you additional marks, because its idea is to whether you understand which process comes, how it should be serially arranged. So that linking has to be there, and it doesn't matter box or circle or 3D box or whatever. It doesn't matter.
Okay, Tom.
Awesome. Thanks very much. I know you say it doesn't mention a sand filter, but the assignment spec does give maturation ponds. Do we need to pay much attention to those? Do we just assume they're 1 meter deep and then figure out the area we need? If we can replace those as well with MBR?
Basically, the depth is basically when we do some calculations, the calculations will give you in terms of volume, right? So And when you when you have the results in terms of volume, then the space is not in terms of volume, because volume has the three-dimensional height.
Yes.
So space is based on the surface area. So that's how where height comes into play. So that if you divide the volume with the height, then you get the area, right?
Yes.
And so this is where but mostly just compare in terms of the area. I forgot to mention in that good or bad example report, some students compare space in terms of volume. So volume doesn't make sense, because you can have, of course, there's a height limitations, the range that is usually given, because if your height of the reactor is too beyond the optimum one, then it doesn't function well. So it's a wastage also. But yeah, space is in terms of the surface area, not in terms of volume.
Yes.
So,
Yeah, I hear you. But just with those, with the maturation ponds, do you want us to account those in the space saving as well, or no?
Where are you referring to? I think there's no maturation pond here.
Oh, the spec gives secondary treatments, and which is then followed by maturation ponds. Do you want us to ignore it or account for it?
Yeah, you can ignore that.
Ignore maturation ponds?
Yeah. So it's, of course, to me, it doesn't matter. Even you can go beyond what is given in the scenario if you are really going deeper. So for example, here we didn't give you the sand filtration, right? Yeah. So in your scenario, you can assume that, like, okay, this is the existing one. Okay, give more than what is there. So for example, primary, let's say you have screening, then you have primary settlement, you have bioreactor, which is aeration and anoxic. Sometimes you can even have a anaerobic pond before that. And then after that, you have a secondary settling tank, then you have a sand filtration. You can even assume that it doesn't matter. And in that way, if you replace this one with MBR, then you can even have more cost savings, right? But of course, in that way, you learn more. Yeah. And you judge based on the quality and the work that you do. It's not just only that, okay, you follow this. So it's the quality of the work that you, so if you do that, then even, you know, we will assume that you have learned more, and the knowledge is broader than the others. So naturally, it's better chances of marks.
So what I hear is there is actually a benefit to assessing those maturation ponds, because it's not just feeling around for the sake of it. You're saying it will actually be reflected in marks. Yeah. Because there will be a broader perspective on the treatment plan. Yeah. Awesome.
So it's the idea of how you draw that perspective there, and then give us the why this comparison has been made and what is its advantage. And so this is because that will give us a feeling of how much depth of understanding of the treatment process that you have.
Okay, awesome. That's great. Thank you. Cheers.
Any other question from other student?
Another perspective. Okay, we got to our results, for example, but I don't think anyone of us has worked in a wastewater plant. So maybe from different papers, you get different dimensions of bioreactors and clarifiers, but that is just, sometimes it's not real life, of course. So when we're going to compare our results to something that's true, maybe our results turn out to be a bioreactor that's so small that you can, it actually cannot be constructed like that.
Yeah.
So do you have maybe rule of thumb, something like clarifiers should be within 20 meters per, 12. And some bioreactors are maybe, for example, the one that I think it's in the Prospect plant or something, those measure about 20 per 20 meters, something like that. You have some measures that we can try to.
There's nothing like that. It's usually given the range of the range for the height they usually given, the maximum size that you can have for one, usually it's given like that. So because your plant size will depend on the capacity, the treatment capacity, right? So treatment capacity can vary depending on the population. So there is no thumb rule that the treatment plant, minimum size of the treatment plant or the clarifier should be this much. There's nothing like that. So you can usually have a thumb rule for the height, thumb rule for the dimensions, how to size the dimension, how much should be the length in terms of width, something like that. Is usually there can be thumb rule, but not in terms of the size. That's nothing like that. So it has to be based on the real calculation. So some adjustment can be there. So for example, if your treatment calculation shows maybe like 1,000 meter cube, then you can design probably 1,200, 1,100 size depending on because when you change the height, because the range of the height is usually given, and based on that, you can either some people will use the minimum one, some will use the maximum one, some will use the average of the two. So those sort of things can be done. But usually we check it whether HRT is usually given and SRT is also usually given. So if it exceeds beyond that, then becomes your treatment plant may not function well, because if your reactor size is too big and your flow rate is too low, then your HRT is very high, right? And SRT will also be very high. So in that way, you are either you over design, oversize it, or that and if you do it too low, then it's the lower size, and then you don't
It
like
overflows.
enough treatment. So there's nothing like that at thumb rule. Okay.
It's just to know that we are not crazy with our calculations.
Yeah.
So any other questions from other students? No more questions? So yeah, I just want to follow up my question regarding whether you want to extend this assignment too. And some of students said no, so we can just go this because it is drag out. And some students want to have 4 more days or 5 days more. So if you agree, because our next assignment 3 lecture will be held next week, end of next week, so that possibly we can extend by Wednesday or Thursday, if we agree, from this Sunday. So what do you think? Everybody okay? Maybe 4 more days? Yep.
Yes, Professor.
How about Ekaterina? It's okay by next Thursday?
Yes, it's perfect.
Assignment? Okay. So we can extend by next Thursday from this Sunday. Also, so how we can interact with each other? So we try to organize this kind of Zoom meeting. So everybody is available time for next Friday for the assignment 3 and then block 3 lectures, Friday afternoon next week. How about next week, Friday?
So we surrender our assignment on Tuesday, Thursday, and we have class on Friday. Not class, but
Just the Zoom meeting.
This one, okay? Yes, of
assignment 3 and then block 3 the material, and then you can read and we can have a discussion briefly on next Friday And then, yeah, before we have a deadline of assignment 3, we can have another this kind of Zoom meeting, Q&A sessions. So we can have 2 more Zoom meetings we are planning. So do you believe we need to extend some more Zoom meetings, or I want to interact each other? If you don't mind, as I mentioned here in this chat, you can leave an email, or if you need any student work together, like Maria can collaborate with some of students, or Dom can collaborate for your assignment, so discuss each other. So if you need any help, so happy to interact and happy to connect. So if you need help from your students, so please let me know. Also, you can find, hopefully some of you know each other, right? So you can discuss, yeah, and then have a better strategy of your class. So that's what we have. Another some question. Everything looks okay.
So Professor, we're going to have the next meeting at 2 p.m. 2 p.m. on next Friday. Yeah.
What time is good for you?
It says it just says that our class we're supposed to be from 2 to 5 p.m. on Friday. So
2 to 5 p.m.
Yeah,
it was supposed to that, but we are Zoom meetings, so it's a little bit flexible. It can be 3 p.m. or 4 p.m. So depending on your time availability, which time is most convenient for you? 2 p.m.
Professor, 11 in the morning would be better. Like
11.
Yeah.
Next Friday.
21 onwards.
How about other student? Next Friday, let me see, 11. For me, it's okay. 5th of June, 11 a.m. How about 11 a.m. next week? So I'm afraid that you may have
okay.
last minute your assignment too on Thursday, and then stay whole night. And I'm not sure whether you can get out at the.
Yeah, that's correct, though.
So that's why it is an afternoon comfortable. If you maybe some of students maybe spend a lot of time at the last minute on Thursday deadline.
I'm the one in there.
So yeah, I don't mind. How about 11 a.m. or 3 p.m.? Which one do you prefer?
Any?
I vote 3.
Three. Okay.
I vote
Yeah,
3. I don't know.
Three is okay, because most of the students, like, they study whole night, and then it's very hard to wake up early morning for them as well.
Okay, fine. Three.
Little bit of worry.
And it's within the time frame of our usual class.
Yes,
Supposedly.
let's keep it. Yeah, because it's better to keep our time schedule. I'm sure that you may ask another extension for assignment 3, so we don't have enough time to finalize all your marking. Also, we haven't finished your assignment 1 marking, so I will follow up with Leonard teasing. So definitely he will provide all the feedback by this week or next week, so that you can read your feedback. But overall, looks like everybody did very good job for the assignment 1. So I will follow up also assignment 1. Any other question?
No.
Professor Sharif, it's for you. Can I go on?
Yeah.
Thank you. Professor, I'm not going to be a very specific, this is not going to be a very specific question, but from the summary of the assignment, I could realize that the whole idea revolves around the design and the comparison, and it's a generic demand of this task. So according to this, what parameters should be prioritized? Like, one is the space. Okay, space is the idea revolves around space, because as Dom mentioned about external and internal submerged reactors. So is it the only space which has to be taken into consideration, or power and all that stuff should be given equal priority? In generic, it has to be given undoubtedly, but for this task particularly.
Yeah, for this task, the two main parameters you're comparing.
Okay.
One, the definite space, and the other is the energy and power.
Okay.
Yeah. So the power, basically, designing is you as a designer, you specify how much power is required for this particular unit process. So that's what you have to design, because energy calculation you can still do because you have power. So once you have power, then you assume that this is your, say for example, if your aeration requires 100 or say 50 kilowatt of power, right? Yeah. So, but then in that case, you already know what is the flow rate or the treatment capacity of the plant, because that's what you're designing. So based on that, you can calculate, okay, how much energy you expected to consume per meter cube. So that's also you can do the calculation. But mostly you are, as a designer, you're expected to calculate the power requirement, because this is what, once you say that, okay, I have my reactor size is this much for this capacity, and then the energy required for my this bioreactor for aeration, then MBR for flux management, and all those sort of things. Well, say I need say 100 kilowatt of power. So this is what you want to calculate, and also then you will have to compare with the conventional activity / process and the MBR, right? So when you do the conventional activity / process, you'll have to do the calculation for what is the power requirement. Now, when you do the calculation for MBR, you also require the power requirement. So then you compare these two and see which process, which technology will consume more power.
Yeah.
Definitely, our calculation is that you'll have more energy requirement or the power requirement for MBR compared to conventional activities. But in terms of space, you'll see that MBR is
a drastic reduction.
Yeah, that's very nice. So this comparison is what you want to be doing. So two main parameters, requirement, the space requirements and energy requirements. Those two comparations.
Because for me, Professor, this is a very negotiating case. Designing a water treatment plant or any membrane system requires a bigger negotiation. Negotiation is from pump, from energy to the membrane use, the pressure required because the smaller the size, the higher the energy requirement on all that negotiation part. So I was very much confused, and I was trying to touch upon every single aspect, but it could be a more tedious if I try to stick on every single aspect, because I tried to go much more into the physiochemical characteristic of the membrane, like the pore diameter, size, flux, and all that stuff. So I just wanted to prioritize
So of course, if you have time, if you can do that, it would be great. It's a good learning for you. But because when we design, we have to design within the limitations of your time, because you have other subjects as well too. So it's just a comparison. Of course, because of very short time, we couldn't really make this a little bit more, because that after this COVID-19 shutdown, many things went online, and then we first we have to remove the exams also. So we increased the marks for the assignment, but we didn't really increase the scope of the assignment. So this is what we should have done, and hopefully in the next batch we will be increasing the scope and then touch in more detail, so that because the marks has increased, the exam has been omitted. So students should have been learning more. So probably in the future we'll have some other design aspects to be included in that, beyond the space and the energy.
Okay, Professor, one more question. While going through the slides, I could see a slide for isotherms, like the mechanism of adsorption. So do we need to even go into that depth, like the isotherm Langmuir, Flenwich, and all that stuff?
No.
No.
It's just most of the slides is touching on the fundamentals of so that you have a broader understanding of how the treatment processes should be working.
Okay.
So you can't just go and straight away to design without understanding the fundamentals. And then, yeah, of course, most of the students in this batch probably would have already covered some of the process that I have lectured in the class, but some students, they don't have not much idea of the treatment processes. So this is why it's for the benefit of the students. We try to incorporate as many aspects of the treatment plant as possible, because you can, so in that way you can have range of options. But if you limit to what limit to what you are going to be involved in the design, then yeah, the learning is not much. So that's why we put in there. But you don't have to use those details in this assignment.
Perfect. Okay, thank you.
Yeah.
One last question, if you have. If you don't have.
Just one little thing, Professor,
yeah.
sorry.
Yeah.
Sorry, just in case, we're saying is we will end classes within a month, more something like that. If social distancing measures are more relaxed within the next month, would there be an opportunity for us to visit the Central Park bioreactor?
All right, that's a good question. We haven't really booked the Central Park at this stage because it was canceled at the beginning of this class. So if you really want to see, definitely.
Or maybe help us reach someone there, so maybe we can do our own site visit. And because I know not all students are going to have the time to do it, but maybe some of us that are really keen on taking that.
All right, because it's not about our decision, it's about the plant, because the plant operator is worried about the social distance access to the plant at this moment, because wastewater, you know, we have several viruses coming to the aerobic reactor, and then we don't know what's the consequences of this impact. So we're a little bit worried about what's the inside, and then what's the virus can be also floating on in the air. So it's really good time to visit, because this wastewater is directly coming from the toilet from the residential area, as well as the restaurant and toilet. So could be some virus would be there. So safety issues, still we are not certain. So that for your health issues, I think maybe we can try to arrange next semester if this is completely lifted all the restriction, or next year we will learn this subject again. Definitely we will have plant site visit if we don't have any problem for this COVID-19. So you can come, and then I will let you know next year. So when is the time we will visit, and then you can come and then join us. That could be another option. So we will let you know when is the best time, because it's not only about social distance.
I know. Thank you.
Yeah,
Sorry,
it's not only about social.
Yes, I know.
This is the little bit virus issue would be there in
defiant for everyone.
Yeah.
Defiant. Thank you.
Okay, thank you everybody, and then all the best for your assignment too. Still, you can communicate through your email, and we can keep getting together, and we will inform you. The most important message today is our assignment due is the next Thursday, extended, and then we have 3 p.m. next Friday, block 3 lecture material. So hopefully you can read everything, and then we can have another Zoom meeting next Friday. So that's all about for today Zoom meeting. Thank you for coming. and see you next week.
Thank you, Professor.
Thank you.
Thank you. Thank you. Thank you.
Bye.
Yeah, bye.
Thank you, Sharu.
Yeah, thank you. Thank you, sir.
Yeah, I will see you tomorrow.
Tomorrow, yeah, yeah. Bye.